Okay, folks, so we are still on section 8.3, dealing with trig ratios, but today we are going to, we're on the back side of your notes, your 8.3 notes, and we are going to work with inverse trig ratios. So inverse trig ratios are actually allowing us to solve for the angle rather than solving for a missing side length. So essentially, if we're looking here for angle A, and let's say, for example, that we know that line segment BC is, I don't know, 5, and line segment AC is 8, then we can say that the tangent of 5 over 8, so we say the tangent of angle A equals 5 over 8, it's opposite over adjacent. Then what we do is we take this word tangent and we just flop it to the other side of the equation. And so then it finds out that the measure of angle A is going to be the inverse tangent of 5 over 8. Okay, and that is something we can just plug into your calculator. So to find it on the calculator, you need to push second, push the second key, and then you push the tangent key. And when you do that, you should get inverse tangent on your calculator. Okay, so there's an inverse tangent, there's an inverse sine, there is an inverse cosine. And all of these allow us to solve for missing angle measures. So let's take a look at an example here quick. And in fact, before we get to the example, let's do some practice with our calculator. So right down here, they tell us that the sine of angle A equals 0.76. So what we do is we type the second key, and then we type the sine key, and that will give us the inverse. And so the way I show my work here is I take the sine and move it to the other side. So now I know the measure of angle A is going to equal the inverse sine of 0.76. So second sine gives me inverse sine 0.76. That means that the measure of angle A rounded to the nearest tenth is 49.5 degrees. Let's try cosine. So again, I need to take cosine, move it to the other side, and so now I have the measure of angle B equals the inverse cosine of 0.17. Remember, inverse trig ratios, what they do is basically they're asking you what angle makes the cosine 0.17. Okay, what angle makes the cosine 0.17? So we are taking the inverse cosine of 0.17, and that gives us the measure of angle B equals 80.2 degrees. And technically that should be an approximate symbol, not an equal symbol, because we did round. Okay, so there's a little calculator work. All right, so let's try an example here. So using a calculator, approximate the measure of angle A to the nearest tenth of a degree. So first off, we want to look at SOHCAHTOA, and we want to look at our triangle. So angle A is right over there. That's the angle we're looking for. But relative to that angle, we are given the opposite side and the adjacent side. Opposite and adjacent is tangent. So therefore, the tangent of angle A is going to equal 16 over 20. Now normally I'd have you reduce down that fraction, but we're going to plug it into the calculator anyway, so it really doesn't matter at this point. But we do want to take that tangent and move it to the other side. So the measure of angle A is then equal to the inverse tangent of 16/20. And remember, what we're asking ourselves is, at what angle is the tangent 16/20? At what angle is the tangent 16/20? So inverse tangent of 16 divided by 20 gives us the measure of angle A to be approximately 38.7 degrees. Let's try one more. All right, finding the measure of angle X. So again, right there's angle X. We need to look at SOHCAHTOA. Relative to angle X, we are given the opposite side, and we're also given the hypotenuse. So opposite and hypotenuse is the sine. So the sine of angle X is 6/10, opposite over hypotenuse. You want to take the word sine, move it to the other side of the equation. So it's now the measure of angle X equals the inverse sine of 6/10. And so we can plug that into our calculator. And we end up finding out that the measure of angle X must be approximately 37 degrees, rounding to the nearest degree like they ask us to. All right, well, just to give you kind of an idea of where this stuff is used, a friend of mine saw a bookshelf that's designed just like this in a catalog, and they wanted like $400 or $500 for this bookshelf. And she decided she could make it herself just as easy, but she did not know how to find out the angle for which to cut this top portion so it lays against the wall nice, and this bottom portion so it sits on the floor nice. So she came to me knowing I'm a math teacher and asked me how to do it, and guess what? It's trig ratios. It's the inverse trig ratios. So what I asked her was, how tall did she want these bookshelves? And I forget what it is, but let's say 6 feet. And I asked her how far from the against the wall did she want it to be. And again, I forget what it is, but let's say 1 foot. And so then by knowing this information, we can solve for this angle up top, which would then tell you how to cut that board. And all that was inverse trig ratios. It is the tangent of the angle we're looking for is going to equal the opposite over the adjacent. And so therefore, the measure of our angle theta, or alpha, excuse me, is going to be the inverse tangent of 1/6. And so the inverse tangent of 1/6 means that that is just going to be a shallow angle of approximately 9.5 degrees. Okay, so again, you never know where these trig ratios are going to show up.